Now that we've learned how to add and subtract rational expressions, our next step, kind of logical step, is to multiply and divide them. And following this pattern throughout this unit, let's take a step back. Let's go to grade school and think about how we learned how to multiply and divide fractions. And you might have had a teacher that say, hey, look, multiplying fractions is the easiest thing you can do with them. You don't need a common denominator. You don't need to change anything. You multiply straight across. Numerator times numerator is the numerator. Denominator times denominator is your denominator. Great, you got an answer. So 2/3 times 4/7. You would multiply 2 times 4. That's going to be your numerator. 3 times 7 is going to be your denominator. And so you get a solution. It's 8/21. And most of us will look at that and go, yeah, that was a pretty easy problem to do. So let's maybe switch things up a little bit. So what if we had a problem like 2/3 times 3/7? So 2 times 3 divided by 3 times 7. And most of us are looking at those 3's and saying, hey, wait a minute. I think there's something we can do with those there. And it turns out that that's true. We've seen already that we're looking for common factors, numerator and denominator. 3 divided by 3 is just 1. And so when we multiply that out and we get 6/21, even if we didn't divide out those 3's, it's pretty easy to see that 6 and 21 both have 3 as a factor. And so we could simplify that after we divide. But if the product was something like 1,035/54, which has common factors, well, those common factors aren't so easy to see. And if that was the case, we'd probably be way better off if we took out the common factor and divided it out before we multiplied those two fractions. I think we can agree on that. So obviously, just like we've done with simplifying expressions, adding and subtracting expressions, our next step is we want to apply this tactic for multiplying and dividing fractions to rational expressions. So these are going to be our steps. Just like we've learned how to do right from the jump, we're always going to factor our expressions first. The numerator and denominator, break them down into their factors. If it turns out that we're dividing, well, we're going to look at that a little bit later on. But you already know how to divide fractions. Once we've identified common factors in the numerator and denominator, we can divide those out. Then we'll multiply and simplify if needed. So let's take a look at a couple of examples. They're going to be relatively simple and see if we can just kind of get ourselves warmed up. So our first one has 6/a² times -2/8⁵. Okay, so I'm multiplying straight across. 6 times -2 is -12. A² times 8⁵, remember your exponent rules. I'm multiplying powers at the same base. I'm going to add the exponent, so a to the 5th. Okay, not bad. We're up and running now. So x minus 5/x plus 3 times x minus 7/x. Now there's no common factors here, nothing that I can divide out on both sides. So we're going to multiply x times x, that's x². X times -7, -7x. -5 times x, that's -5x. And then 5 times 7 is 35. In the denominator, x times x is x² plus 3x. And let's simplify because we've got some like terms here. X² minus 12x plus 35 over x² plus 3x. Not bad. So now let's jump in with a couple more challenging problems. So x² over 8x times -8x minus 16 over x² minus 4. So let's break these things down. I have x minus 2 over 8x. Here, I can factor out a greatest common factor. -8 times x plus 2. X² minus 4 That's x plus 2 and x minus 2. So let's see what we can do now. My x plus 2 has a pair in the denominator. My x minus 2 has a pair in the numerator. I have a negative 8 divided by a positive 8. That's negative 1, and that's all that's left in my denominator is x. So this equals negative 1 over x. So this whole big expression, when I simplified it down, negative 1 over x. Let's look at another one. So 3x plus 1, nothing I can do there, no GCF, over 4. And then I have an 8x in the numerator, 9x squared minus 1. So these aren't real obvious, but 1 is a perfect square, remember, it's 1 times 1. 9x squared, that's 3x times 3x. So this is the difference of two squares. It's 3x plus 1, 3x minus 1. All right, so let's look for our common factors now. So I can see that my 3x plus 1 has a pair. 8 divides by 4 and 4 divides by 4. So in the numerator, I have 2 times x. The denominator is 3x minus 1. You go ahead and try and work out examples number 5 and number 6. Come back and we'll check our answers together. All right, if you're ready, let's take a look at your work. So we factored x squared plus 7x plus 12 as x plus 4 times x plus 3. That meant we could divide out x plus 4 in the numerator and denominator. We multiplied out those two binomials in the numerator and got 5x squared plus 16x plus 3 over 3. For number 6, all GCFs here. 2 times 2x plus 3, 3 times 2x plus 3, 3 times x minus 5, and all the binomial factors paired up, plus I had a factor of 3 in the numerator and denominator. All the factors in the numerator I was able to divide out. So remember that leaves me with 1, and in the denominator just 2. So number 6 was equal to 1/2. So let's think about dividing now. Mathematically speaking, when we divide by a number, we're actually multiplying by its reciprocal. So we need to flip or invert the second fraction and then multiply. So again, let's try a couple that will be, I think, not too challenging for you. Get our feet wet on these. So the first thing we need to do here is invert the second fraction. So a, the denominator, becomes the numerator, and a minus 2 becomes my new denominator. And so now a minus 2, those factors I can divide out. I have a pair for my a. So remember again, I've divided out all the factors in the numerator. That leaves a factor of 1. And my denominator is b. Let's take a look at number 8. So let's go ahead and rewrite the whole thing first. We're going to multiply, invert that second fraction, x squared minus 49 over x plus 8. Now let's factor. Two numbers that multiply to make 40. Then when I add them up, I get 13. That's x plus 8, x plus 5 over x minus 7. Here, difference of two squares, x minus 7, x plus 7, and x plus 8 in the denominator. So let's look for pairs of factors now. There's an x minus 7 that matches up. There's an x plus 8 that matches up. My denominator now is just 1. All the factors have been divided out. So I have x plus 5 times x plus 7. Let's multiply that out. X squared plus 7x plus 5x plus 35. So x squared plus 12x plus 35. All right, a couple more sets of examples. Go ahead and stop the video, try and work through these on your own, and then check your answers. So once we factored out our GCFs, there's an m plus 2 that pairs up. There's a factor of 7 that pairs up. So what remains? 5 times 2m minus 3 over 2 times m minus 10. Multiply those back out. So I have 10m minus 15 over 2m minus 20. And this all looks like maybe there's something in common there, but we already recognize that there is not. That's as simplified as this can be. Reminder to ourselves, here I'm dividing by what would be the basic equivalent of a whole number. I need to multiply by its reciprocal. So let's walk through that one together. 3x squared over 2 divided by negative 15x to the fifth. When I invert that, it's going to be 1 over this. So let's see what happens here. 3 divided by 3 is 1. Negative 15 divided by 3 is negative 5. I have 2 copies of x here. That pairs up with 2 copies of x here, leaves 3. All my factors in the numerator have been divided out, so I have just 1. 2 times negative 5 is negative 10. X to the third. Okay, into the home stretch. Do these on your own. Check your answers. Into the home stretch on number 11, I can see that there's an m plus 5 that pairs up, an m minus 3 that pairs up, and 1 over m plus 4 is the simplified form of that one in number 11. All right, same story on number 12. Okay, this one took a little bit of work. You should have got 2x minus 3, the quantity, times x minus 4, that quantity squared, over negative 18x. So pretty good work on these. We're building on what we've done in the past with factoring, simplifying. Now we're multiplying straight across, and when dividing, we're multiplying by the inverse. Don't forget to take some time, and let's cement some of this new information in your memory. So you want to take some time, sort through what you've learned, 3 things that you've learned today, 2 things you want to know more about, 1 big question you still have, and lots of space at the bottom here if you're the type of person that sketches out graphic organizers, connections, summaries in words, sketches, pictures, graphs, anything like that that helps you to remember what you've learned today.